Okay, here is the answer key for this last review test, review quiz, whatever you want to call it. I'll go through this fairly quickly since I've written out the answers. This is also posted on Moodle, by the way. So the original problem here is a simple quadratic. I've done you the favor of moving it all over, setting it equal to 0. You definitely want to be aware that that is the first thing you do with most quadratics is you shove them all over to one side, set them equal to 0, and then use any one of the various techniques we've learned. In this case, I've asked you to do this by factoring. You always want to look and see if there's a common number or even variable and number you can factor out of everything. All of these are divisible by 3, so I do that. When you divide 0 by 3, you get 0. It just reduces to this, and this hopefully will be easy factoring for you. The plus sign says that they're both the same sign. They're both whatever that sign is. It's minus. Two things that multiply to make 15, that add up to make 8, 3, and 5. Don't forget to write the actual solution. Each of these factors has to be set equal to 0, and that's only going to happen when it's positive 3 and positive 5. Okay? The next one I want you to be super aware of the layers that are around the x. I've numbered these. The first layer is that 3. If you follow the PEMDAS rules, multiplication is done before addition. So this makes this, or subtraction, makes this the second layer. And then the parentheses are the next layer with the exponent out there. And then next to that is the 3. And then the outermost modifier is that number 1 right there. That's the fifth layer. So we do them in reverse. We peel away the layers from the outside to the in, just like those Russian dolls I told you about. So I take away that 1 from both sides, and 49 goes down to 48. I divide 3 by both sides, and that 48 goes down to 16. I take the square root from both sides, and I go from 16 down to plus or minus 4, and that radical has gone away. Square rooting a square cancels out. Now I just have to take away the negative 2 by adding 2 to both sides. 2 plus 4 is 6. 2 minus 4 is negative 2. That's what 3x is equal to, so then I divide both of those numbers by 3. 6 divided by 3 is 2. That's one of our solutions, and negative 2 divided by 3 is negative 2/3. Okay? On this next one, you're asked to do this by completing the square, so you're going to need to show the steps that you know how to do this. Again, we can't complete the square until we've gotten rid of any coefficient out in front of the x squared. So just divide everything by that number. Fortunately, I'm being nice here. I've given you a number that divides evenly into by 5, and then it also gives you an even number, which is easy to take half of that. Half of 2 squared is 1, so I fill in that number there to complete the square, which allows me to then factor it and write it in that exponential form really simply right there. And then I just have to do the math. You have to grind through those fractions. Your calculator can help you a little bit, but 7 over 5 plus 1 is really plus 5 over 5 to get the common denominator. And then you get 12/5. I take the square root of both sides. I come over here, and then I subtract 1 from both sides. This is the exact answer, but put it into your calculator and you get 2 approximate answers. At least I hope that's right. I estimated that. Here, this problem number 4 is quadratic formula. Make sure you have that memorized. If you don't, you're in tough shape. I plugged in all the things very carefully. 61 is prime, so you don't have to go through any kind of factoring tree to cancel. But you should know how to do that if you have to. And you get the exact answer here, and then you get the decimal approximations right there. Okay. This last one on this this page of the key, just make sure you distribute the 2x in carefully. When you do that, you'll see, I hope, that you get a negative 8x on both sides, so they simply cancel. When you have x squareds on both sides, you want to bring them all over to the side where they're large and positive, so I take away an x squared from both sides to move the one x squared over. And then if I have x squared by itself, this is the one example where you don't want to get 0. If you have x squared minus 9, that's fine. Set it equal to 0 and you factor it and you get x plus 3, x minus 3. Or you can write it like this and take the square root of both sides. Then you get your final answer. That's both the exact and, of course, any decimal approximation will be the same as the exact in a situation like that. Alright, now on to calculator explicit stuff. You can't solve this without knowing how to do quadreg in your calculator. You put 1, 2, 3, and 4 into L1 of your calculator. You put 6, 11, 18, and 27 into L2. Then you just go quadreg on it. and you'll see that A is 1, B is 2, C is 3. Okay? When you plug that back into the quadratic form of that, you just get 1x squared plus 2x plus 3. Plug in 1,000, you'll see it's 1,002,003. Okay, there's your 1, your 2, and your 3 in this case. Alright, now this one I'm going to do on the calculator, but I'll show you the algebra part first. This is in standard quadratic form. The minus there tells us that it's going to be an upside down parabola. When objects are going projectile through space, they're going to follow a parabolic path, and there's some simple things that you know that at the start, when x is 0, these terms just drop out, and it's being thrown, I guess it's a lacrosse ball being thrown from a height of 2 meters. So the first question asks, when does it come back down to that same height? Well, you just set that equal to 2 meters, the 2's cancel, and you get x in both places here equal to 0. So it's actually a fairly easy factoring problem. This often strikes new students to this subject, like you guys, a little bit strange, so I wouldn't expect you to find this an easy way to solve it, but I just wanted to show you that this is mathematically a very simple way to do it. If you put it on your calculator, which we can jump to now, okay, here is the equation typed into the calculator. Consider the problem carefully before going to the window. I've set my x minimum just a little bit to the left of 0 so I can see the axis. I know that a lacrosse ball can only be in the air for like 6, 8, 10 seconds. So I've got 6 here. My scale is just how frequent my marks are. The y height I'm going to show from below the axis. Again, I like seeing the axis. Sometimes the numbers are obscured. If you get it too close, set it to 0. But a ball can maybe go 50 meters high if you're really throwing it high. And then the scale is going to be about 10% of that, or about 10. If I go to my graph, you can see I've tweaked it a little bit so it works out really nicely. If I go to trace, I can trace the height of the ball as it moves, right? So I can certainly answer when does it get to a height at which it was thrown originally, which is 2, by looking very carefully over these numbers. It's at 20 now, moving down rapidly, 6, 4, and there it's at 2.4, and with one click it's going to drop below there. So that's pretty much my closest answer, 5.58. Okay, and 5.585 would round to 5.9. If I wanted to be more exact, I can do it a couple ways. I could go to y equals, I could just go down here, I could type in 2, and then go back to my graph, and you'll see I'll get a line at that level. And there's a way my calculator can find the exact point of intersection. I would do zoom, trace, second trace, and choose intersect. That's option number 5. And then just pick the 2 curves. In this case, there are only 2. I don't know why they call them curves. Hopefully I'm going to get the oops, I've gotten the one that's very close to the 0. I'm going to do that again. I definitely should have steered over. So I go to intersect, and I have to kind of mouse my cursor over to be closer to the second 0, or the second point at which it will reach the height of 2. Alright, now at least I'm on that side. I'm closer. I go enter, enter, and enter, and you'll see that it's at 5.6, okay? Which is the same as the algebra version of this. If I go in here and factor this and solve this one, this factored part is only going to be equal to 0 when it's exactly 5.6 seconds. Okay? So then if I go back to the calculator and try to find the point at which it hits the ground, that's going to be a 0. So I can do second trace and then choose when it's going to be at 0. And I just have to bracket it to be slightly to the left, which I am when I'm above the horizon, and it's going to be to the right hand side when I'm in negative numbers for my y values. I hit enter again, and my 0 is at 5.67, and then I'll round it to 5.67 seconds. It will come back down and hit the ground. When does it get to the maximum point? Same type of thing, second and trace. Gives me the calculate menu, and I can go and find the maximum. That's 4. Again, you've got to bracket it, as it's called. I have to be slightly to the left of the maximum, and then choose enter, and then be slightly to the right. You guys shall have done this a bunch of times by now. You really should be experts at this. Okay. and I hit enter, and now I'm bracketing it, and my maximum is at 2.799999. When you see that, that's just the calculator being silly. It's losing a little tiny bit of accuracy there. It's really 2.8. Alright, so round that to 2.8. I think when we get to there, we're pretty much done with this. I found the zero using the quadratic formula. I found the maximum height by using the minus b over 2a to find that axis of symmetry number, and I sub it in, and I'll get the coordinates for that maximum height. Oops, I did not. I guess I can go back to that to show you that the actual maximum height there is 41.2. But that is pretty much it. So good luck studying, and see you guys on Monday.